Hey guys, what's up? We're looking at how to graph linear inequalities. It's a lot like graphing equations, except now you have some shading because there's lots of solutions instead of a line of solutions. So let's look. First thing you're going to need to know are what your symbols tell you about your graphing, right? Just so you know, it's easiest if we convert to slope-intercept form, y equals mx plus b, except it's not equals, it's an inequality. We're going to draw our line first, just like with equations, and then we'll learn how to shade that solution area. Okay, so you have to know that all of the inequality symbols tell you something about your line, and it tells you about your shading. Okay, so a solid line are any of the ones that include the or equal to, right? So when we're looking at this, if my symbol is less than or equal to, or if it's greater than or equal to, then my line when I draw my graph will be a solid line. Okay, so then dashed lines is not equal to. That means that the line is not part of the solution. It's not part of it, right? So that would be our less than and our greater than symbols. Okay, now when we're talking about shading, I want you to always reference your y-intercept. That's why having it in slope-intercept form is awesome, right? So we shade above if we end up with an inequality that says y is greater than, or if it says y is greater than or equal to, that would shade above the y-intercept, which means if it's below, then we're looking at something that says y is less than, or y is less than or equal to. Okay, so know those symbols. We're going to be looking at those, refer to those like, okay, what does it look like? What is my line, solid or dashed? Do I shade above or below? So you have your kind of step-by-step things to think about. When it's in slope-intercept, plot our y-intercept, use the slope to find another point, connect your dots, extend the line, make sure you're thinking, is it solid or dashed, and then we shade. Okay, and we can use the calculator to check as well. So here we go. Example A, y is greater than 1/2 x minus 4. This is mx plus b, right? So here's our y-intercept, which is always what I plot first. Y-intercept means the first point on my y-axis, and so I go to -4, plot my point. Okay, this m, that's a jacked up m, guys, we'll pretend. Okay, m is our slope, and this is our driving direction, so it's +1, so I go up 1, and I go to the right 2. So I'm going to go up 1, and to the right 2, there's another point. Up 1, over 2, there's another point. Up 1, over 2, there's another point. And just to go backwards, I could go down 1, to the left 2, and notice it keeps with my pattern. So cool. Down 1, to the left 2. And now I look at my symbol before I draw my line. This is just greater than, and so it's going to be a dashed line. So I'm going to use a ruler, but I don't have one, so we're going to pretend I'm drawing a super dope straight line here. All right, you should have a straight line. All right, so we've drawn the line, we plotted points, drew our dashed line. The last thing is looking at this. This says y is greater than, so that means to shade above the y-intercept. So everything up here, right? And it's this whole area. Anything that's above there is part of our solution. Okay, and so we're going to tell ourselves this is solution. This part is not the solution. Okay, and remember, dashed means not solution either. So if it's on the line, it's not part of our answer right here. Okay, all right, so the second part of this is which of the following is a solution to the inequality? That means which one is up in the solution part. So we're going to plot them. So I go to 5, -5 is right here. I'm going to label it. That's not in my shaded region. Nope. All right, I go to 1, -4. Close, but nope, you don't fit. Okay, and then I have 2, positive 2. Okay, there is the point that's a solution. Okay, and you could check that if I plug in. So this is x, this is y, right? So if I plug in 2 is greater than 1/2 of 2 minus 4, and then I solve, 2 is greater than half of 2 is 1 minus 4, 2 is greater than -3. Woohoo! There's our check. Okay. You can also graph this in your calculator and see does everything match. All right, let's do one more. Okay, y is less than or equal to -3x plus 5. So first y-intercept. So I go to positive 5 this time. And then this is my slope. And remember, if it's this whole number, I always put it over 1. So this says go down 3, right 1. So I go down 1, 2, 3 over 1. 1, 2, 3 over 1. Down 1, 2, 3, right? And then I look here at my symbol. It says or equal to, so that's a solid line. So we're going to, and please use a ruler. I'm doing a horrible example right now. Okay, we want a straight line, not my jacked up crazy line. Okay, so now we're looking at where do I shade. This is y is less than or equal to. So that means we want to shade below our y-intercept. So we're looking below. So all of this side this time is the solution. And this side then is not part of the solution. Okay, and now let's see which of these points are actually in our solution. So we have 6, 5. So I go to 6, I go up to 5. That is not part of the solution. I go 3, 3, 3 up 3. Not a solution. And then I have -2, -3. Yay, that is in our solution. Awesome, there we go. Okay, so that's how you do it if it's slope-intercept form. Plot your y-intercept, use your slope, find your other points, connect, look at it, is it solid or dashed, and then use that front part to tell you, is it above the y-intercept or below, and that's where you shade.